Okay, so in the previous video, we were able to fill up the first three rows. So we're at the third, so we're at the fourth row now. And in this row, we weren't given mass. Mass is unknown. Okay, so the row is empty. Mass is unknown. M unknown. We were given pressure to be 1 bar. Pressure P equals 1 bar. We weren't given saturation temperature. Of course, we have to look for it. We have to look for saturation. We are given volume. Total volume was given. Volume V is actually 1.01 meter cube. And what else? We are given degree of superheat. Degree of superheat to be 138.6 degrees Celsius. Okay, that's all we have. So we have to find internal energy, enthalpy, dryness fraction, saturation temperature, and then mass. Okay. Okay, so we have these conditions now, and of course we need to obtain the dryness fraction before we can be able to do anything at all on this table. So to obtain the dryness fraction, first of all, we're given degree of superheat. Recall, degree of superheat is actually superheated temperature minus saturation temperature. So let's find saturation temperature. So at the given pressure from saturated water and steam, at this given pressure, the pressure was given as 1 bar. Okay, so at 1 bar, okay, we can obtain saturation temperature to be equal to, so let's get our steam table. This is superheated steam, this is saturated water and steam corresponding to pressure 1 bar. Okay, this is pressure, this is 1 bar. Saturation temperature there is simply 99.6 degrees. So saturation temperature there is 99.6 degrees. All right, so I have that to be 99.6 degrees Celsius. Okay, so that gives us saturation temperature. So we can fill up that space now. Here is 99.6. Okay, next. Okay, so from here, let's obtain superheated temperature. If we make superheated temperature subject T superheat, it becomes what? Degree of superheat plus, of course, negative sign crosses here, becomes positive, so it becomes plus saturation temperature. So it means superheated temperature itself is simply 138.6, which is degree of superheat, plus 99.6, and that simply implies that superheated temperature is equal to, so we have 238.2 degrees Celsius. Okay, so since T superheated is greater than T saturated, it means steam is actually a superheated steam. It means steam is superheated, and for superheated steam, therefore dryness fraction X is simply equal to 1. For superheated steam, the dryness fraction is simply equal to 1. So it means here dryness fraction is simply 1. Okay. All right. So having known that, now next thing is to find the mass. Okay, let's find the mass. We already know the total volume. Volume was given. Recall, total volume V is simply what? Mass times dryness fraction times volume at the gas. So we know the dryness fraction to be X, and that's simply 1. We make mass subject. That simply implies that mass is equal to total volume all over X Vg. Okay, so now we obtain Vg at 1 bar. Pressure that was given is simply 1 bar. Okay, Vg from saturated water and steam. Vg from saturated water and steam, this is 1 bar. This is Vg 1.694. So we have that to be 1.694. Vg is simply 1.694 meter cube per kilogram. So if we know this, that simply means mass is equal to, total volume was given as 1.01, sorry. So we simply have 1.01 divided X is 1 times 1.694. So this is actually 1.01 divides 1.694. That simply implies that the mass itself is equal to. Alright, so that gives us approximately 0.60 kilograms. Okay, so the mass is 0.6. Mass here is 0.6. Okay. Next to find the enthalpy and the internal energy. So let's start with enthalpy. Of course, specific enthalpy, we already know H is simply equal to HF plus X HFG. So we'll obtain HF and HFG from saturated water and steam table corresponding to 1 bar. So HF is equal to corresponding to 1 bar here. This is 1 bar. Okay, the very first HF there is 417. HF there is 417. HFG is in the middle, which is 2558. Okay, so HF is 417 kilojoules per kilogram. HFG 2558 kilojoules per kilogram. Okay. Alright, so we can now find specific enthalpy to be equal to HF 417 plus X. Dryness fraction here is 1. So 1 times HFG, which is 2558. Okay. So this is actually saying 417 plus, of course, 1 times this still remains 2558. So this implies that specific enthalpy is equal to 2558 plus 417. That simply gives us 2599 kilojoules per kilograms. Of course, we'll have to convert to total enthalpy, and that's simply mass times specific enthalpy. Okay, this is now equal to the mass was obtained as 0.6. So we simply have 0.6 multiplies 2599. This implies that total enthalpy H is equal to, that gives us 1559.4 kilojoules. Okay, so that's that for the enthalpy, 1559.4. Okay, so that's it for the enthalpy. Next is internal energy. And of course, still the same relationship. Specific internal energy is simply UF plus X UFG. So still at 1 bar, saturated water and steam table, UF will give us, still here, let me zoom it a bit, still at 1 bar, UF, which is this. Okay, UF is still 417 and UG is 2506. So we still have UF to be 417. Okay, UF is still 417 kilojoules per kilogram. We have UG to be 2. Okay, let me get that again. 2505. So UG is 2505 kilojoules per kilograms. So we can find UFG. That's simply UG minus UF. So UFG is UG, which is 2505 minus 417. This simply means UFG is now equal to, that simply gives us 2088 kilojoules per kilograms. Therefore, specific internal energy is equal to, so we said UF, which is 417 plus X. X is Dryness fraction, and that's 1 times UFG, which is 2088. U is equal to 417 plus, of course, 1 times this remains 2088, and this is actually equal to 417 plus 2088, that's 2558. 2505. Okay, so we'll have 2505. Okay, so this becomes specific internal energy. Of course, total internal energy is simply mass times specific internal energy. The mass itself is 0.6 multiplied by specific internal energy, which is 2505. Alright, so total internal energy is now equal to, that simply gives us 1503 kilojoules. Okay, that becomes internal energy. Okay, so we'll have here 1503. Okay, alright, so that's it. Okay, so I'm going to pause the video here. Of course, I'm going to pause the video here to do the next video for the next row. Okay, so we're doing this row next. Alright, so I will see you in that video. Thanks.